Hello and welcome students. This is Mathematical Logic lecture number 6. Lecture number 6. So in today's lecture, I am going to teach you truth table. Truth table of statement patterns. Truth table of statement patterns. So now you will have a question that what are statement patterns? It's going to take hardly few minutes to understand what are statement patterns. So let's see what is a statement pattern. So first of all, I will define a statement pattern here. Statement pattern. So the name itself suggests that it is going to be a statement and there will be a pattern, and hence it is known as a statement pattern. So suppose there are some component statements P, Q, R and so on. Okay. Let P, Q, R, etc. be the component statements. A compound statement obtained from these component statements or simple statements, whatever you can call them, from these component statements by using one or more connectives. What are those connectives? They are and, or, implication, double implication, negation. Okay, so I repeat the whole thing once again. Let P, Q, R be the component statements. Now what you are doing is you are getting a compound statement. How? Obtained from these component statements. You are getting a compound statement from these component statements and one or more of these connectives. You are using component statements along with the connectives. So when you use a component statement along with connectives, what you get, students? You get compound statement. Okay, that compound statement is nothing but the statement pattern. Is called a statement pattern. Okay, so if I write the examples of statement pattern, so for example, see here, I can have P and Q, double implication R. See, this is a statement pattern. What are we using here? We are using component statements, 3 component statements, and what more are we using? We are using 2 connectives. So what we said here is what is applicable there. So here we have PQR component statements. Then we are using a compounds. We are obtaining a compound statements from these component statements and using one or more connectives. Okay, not necessarily you will have 3 component statement. You may have 2 component statement. You may have more than 2 component statement. Okay, so this is one example of statement or statement pattern here. Next, I give you one more example for this. See, one more example can be P and Q implication R. This is a statement pattern. It is another statement pattern. Okay, see, I can have one more example. It is P or Q double implication P. Now here we have only 2 component statements. There is no R. This is also a statement pattern. So what are statement patterns, students? Let's have a revision. When we are using component statements along with one or more than one connectives, then the compound statement which are formed, they are known as statement patterns. I hope you all have followed this. After having learned the statement pattern, the next point that we are going to do is to prepare truth table. Truth table for statement pattern. There are certain pointers to be remembered. Pointers to be followed for preparing truth table. Now, what are the pointers, students? I shall tell you that. Pointer number 1. If a statement pattern involves n is a number, n component statements, like P, Q, R, etc., then in the truth table we will need 2 raised to n rows, 2 raised to n rows for all possible combinations, of truth values of component statement. So how many component students, how many component statements, students? N. So if there are n component statements, I will need total 2 raised to n rows. Now why 2 raised to n rows? Why not 3 raised to n? Why not 4 raised to n? Why 2? It is because P and Q, P, Q, R, all these component statements have only 2 truth values. They have only 2 truth values. Each one of them will either be true or it will be false. So since there are only 2 truth values that they can have, we are going to have 2 raised to n rows for covering all possible different combinations of the truth value of component statements. So what you have to remember in short, that if there are n component statements in a statement pattern, then I will need 2 raised to n rows. I will need 2 raised to n rows. So if there are, remember, if there are 3, then I will need 2 raised to 3, 8 rows. If there are 2, then I will need 2 raised to 2, that is 4 rows. You don't have to worry, because in our syllabus of 11th and 12th standard, we have maximum a statement pattern having 3 component statement. We are not going to have more than 3 component statements where we will be asked to make a truth table. Okay, so the truth table that we have to make in exams, it will have maximum 3 component statements. So 2 raised to 3, that is maximum 8 rows we have to go for. This is the first pointer. I hope you all have followed. Now we will go for the second pointer. See here, second pointer. Second pointer is, if a statement pattern involves m. What is m? M is a number. If a statement pattern involves m connectives and n, which is again a number, n component statements, then the truth table of the statement pattern will need m plus n. Remember students, if m is a number, n is a number, then m plus n has to be number plus number, a number. So the statement pattern will need m plus n columns. It will need m plus n columns. Okay, now third pointer. So let me have an explanation for this. Suppose I have a statement pattern here. P implies Q and R. P implies Q and R. Okay. Okay. So here, how many columns I will have? See, 1, 2, 3. 3, n is equal to 3, and 1, 2. How many connectives? 1, 2. 2 connectives, right? So m equals to 2. So this statement pattern, if I go for the truth table of this, it will have 2 raised to n, that is 2 raised to 3, that is 8 rows. It will have 8 rows, and m plus n, that is 3 plus 2, that is 5 columns. It will have 5 columns. Okay. Now let me have one more example. See, suppose I have negation of P and Q implies R. Negation of P and Q implies R. So see here, what is n here, students? N is 1, 2, 3. Remember, how many component statements? P, Q, R. 3 component statements. So here n equals to 3. Okay. Then how many connectives? See here, connectives 1, 2, and 3. So m equals to 3. M is also 3. Okay. So here I have to first go for the number of rows. So number of rows is 2 raised to n, that is 2 raised to 3, that is equal to 8. So I have 8 rows. Okay, 8 rows, like this, like this, like this. You remember that? We have 8 rows. We will have 8 rows in the truth table. Okay, fine. Then the number of columns. Here I have m plus n, that is equal to 3 plus 3. I will have total 6 columns. How many columns I will have? I will have 6 columns. So I hope the 2 pointers are clear to you. Let's see the third pointer. The third pointer is while preparing the truth table, of a statement pattern, we will follow the pattern from extreme left to right, one by one, and the parenthesis. What is meaning of parenthesis, students? It is bracket, that is brackets. Okay, like when we write brackets, see P and Q, so this is known as parenthesis. The parenthesis should be given higher priority. It should be given higher priority. That is, we should first handle the parenthesis, the statements which are within a bracket, that should be handled first. Okay, so I will explain you what do I mean by this particular statement which I just wrote. Okay, so see what do I mean by this. I wrote, while preparing the truth table of a statement pattern, we will follow the statement pattern from extreme left to right. Okay, what does it mean? See here, suppose I have a statement pattern here, negation of P and Q implies R. So I have to follow from extreme left to right. Okay, so what does this mean? I shall first go for, when I'll be preparing the truth table, as you all know, students, the first 3 columns are always PQR. So PQR, these are the first 3 columns. Okay, they are always fixed. You know, the first 3 columns will be PQR if there are 3. Then I said that I'll be following the statement pattern from extreme left to right. So see, this is my left, this is my left, this is my left, and this here is right. So I will follow it this way, in this direction. Okay, so I'll be following this. So what will I have next? The next column I will have, see, PQR I have already written. So the next I will have negation P. Okay, see, I am following from left to right. So I will go for negation P. Then see, then I will not go for and. Instead, I will give priority to parenthesis. Look at this, the bracket. Then what I will go for, students? I will go for the bracket. That is Q implies R. Now, once it is done, then what I go for, students? Then I will go for negation P and Q implies R. So here I will have negation P and Q implies R. Okay, this is all going to be very simple. Don't worry, because when we'll be solving problems, you will have a live example for this, and that will make it more clear. So now we are going to make a truth table. We will prepare a truth table for the statement pattern. Let's have a truth table for the statement pattern. This is the statement pattern we have. We have to make a truth table here. So what is the first thing? My answer will begin. What's the first thing that I have to note? So I will first write the number of rows. How many number of rows I will need? See here, students, I have component statement as P, then I have R, 2, and I have Q. So there are total 3 component statements. I will have 8 rows. So n equals to 3, okay? This means 2 raised to n, that is 2 raised to 3. This is 8 rows. I will need 8 rows. Fine. Okay. And then how many connectives I have? So see here, 1, 2, 3, and 4. I have 4 connectives, right? So I have m equals to 4. So m plus n equals to 4 plus 3. I will have, that is 7 columns. I will have 7 columns. Okay. Now there is one thing I would like to tell you, students, that this part which we did here, you may or may not write in the solution. If you want, you can skip this. You can skip this. This is not the part of the solution. If you are writing, there is nothing wrong in this, but if you are skipping it, it is still okay. Why? Because they want us to get the truth table, okay, and which we will do. That will be the final answer. So here I will begin with it. So what was it? The statement pattern, let me write here once again. The statement pattern was P and R implies, P and R, that was in a bracket, then implies what I had in another bracket P or negation Q. This is what I had, right? Okay, I hope I remember it. Yes, fine. So now what I do is I will go for the truth table. I want you all to follow very keenly and attentively. So see here, first I will go for the header. The first one I do is I go for the header. So this is my header. Okay, and after header, see in this header what I will write here P, okay, then the next column is Q, and the third column is R. So these are my 3 columns. So this is, as you all know, that always the first 3 columns will be P, Q, and R. Now students, when you are drawing it, you all have the ruled notebook, okay? So the notebook that you are writing on, the notebook is already having horizontal lines, okay? You already have such horizontal lines. So you may not draw the horizontal lines. You will have to draw only the vertical lines in order to get the columns. This is done, okay? Then I will go for 8 rows, okay? 8 rows I have to go for. So this is header. After that, I need 8 rows. So this is number 1, then number 2, number 3, number 4, number 5, 6, and 7. This is 8. This is going to be very simple, students. This is 8. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's good. So this is, I have 8 rows here. I have, fine. After that, what I will do is, this is my header. What more I can do is, now I shall write the all possible truth values. So as you know, how do we fill this? This is T, 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 T. The first 4 you write T. Remember, first 4 you write T in the first column for P. Then F, 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 F. The next 4 you write all false. Then for the second column, which is Q, you will write T, T, F, F. Then T, T, F, F. That is 2T and then 2 false. 2T, then 2 false. Then the third column, which is R, you will write true, false, 1T, 1 false, true, false, and true, false. Okay. Then we go for the next column. Now see, students, if you remember, we are going to have seven columns. So 3 columns are already done. Now we will have 3 more columns. So see here, how do I go ahead? You know, when I see negation, this is by understanding. Okay, so I had told you that we will follow from left to right. That is okay. But then when I see some negations, I follow that first. Okay, so here I have got negation of Q. Okay, what I have negation of Q here. So what I do is I go for negation of Q. Okay, this is my one column. I go for negation of Q. I write negation of Q. Okay, so if you have negations somewhere in the statement pattern, you should first go for it. Negation of Q, I go for, fine. After that, I go for the, see, negation of Q, I went for. Then I will go for the first bracket here. So first bracket is, I get here P and R. Okay, I go for P and R. This is my one more column I got, fine. Now, after I went for negation of Q, then I went for P and R. I went for P and R. Okay, then what I will do is I will go for second bracket. Second bracket is P or negation Q. Second bracket is P or negation Q. See, I have already got negation Q. Now you will understand why I said negation Q to be written first, because I understood that in the second bracket, I will need negation Q. So for that, negation Q should have been obtained in beginning only. The first three columns will always be what I have written here, always PQR, the component statements. The first three columns will be this. Now negation Q, what will be negation Q? Whatever truth value of Q you have in the second column, you have to negate it. Negate it means if it is true, write false. If it is false, write true. Okay, so here I have false, false. See, here Q is false, so you will have true. This is false, so you will have true. Now here it is true, so false, true. So here you write false, false it is here, so true, and this is also true. Done, well done. Now see, come to the fifth column. See, what is fifth column? Fifth column, I have the conjunction of P and R. P and R. See, I have conjunction of P and R. So P is first column and R is third column. So I have to get the conjunction of these two columns. Remember students, the conjunction of these two columns. This column with this column. Please mind it. The conjunction of these two columns. Okay. So let's do it. P and R. You know the law. What's the law? P and R, when the truth values of P and R both will be true, then true, otherwise false. So see here, true, true. This is true and false. So first let me complete all where it is not true. So see, true and false. So this is false. Then here true and true, true and false. So this is false, false and true. So if these all are false, see, false and true. So false, false, false and false. I could have written all four false immediately because see, for P, I see all here false. You know the conjunction law. What's the law for conjunction? Both needs to be true. P true, R true, then this is true. So see here, true, true, this is true. Now you can fill for true. And true, true, this is true. Elsewhere it all were false. Okay, great. Now we have, see, now we have the disjunction of P and negation R. We have disjunction of P and negation R. Okay, so this time which columns we have, students? P is first column and negation Q. I'm sorry, I said, I think I said negation R. It is negation Q. P or negation Q. And the fourth column, P or negation Q. I have the disjunction of these two columns. So see, how do I go ahead? What is the law for disjunction, students? The law is when both are false, then false, otherwise true. So I will first search for both. I will search for both false. So see, since this is all not both false here, see, P is here and negation Q is here. Okay, so are both false? No. So this is true. Then here, true. Then here, true. See these two. Okay, now see these two, true. See these two, false, false. So false, false. See these two. Are both false? No. So true. So true. Okay. Then we have, finally we have the implication of P and Q, P and R with P or negation Q. Got it? So P and R is in fifth column. This is in fifth column. Fifth column implication with sixth column. Okay. And what is the law, students? The law is very simple. We all know if I have true implies false, then it is false, otherwise true, okay. So what I'm going to do here is true implies false. I will check for that. So do I have here, look at this, these two columns you have to look for, these two columns, this column and this column. Okay, so let's go ahead. Okay, so true, false. No, it is not true, false, true. This is no, 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 no. All are no. So what it is? All are true. All will be true here. Remember, students, I'm going to get all true. Why all true? Because I did not get anywhere true, false. See, true, true. So true, false, true, true, false, true, false, 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 true, false, true. I know the law for implication. What is the law? If I had true as this and false as this, then only I would have written false. If I have true implies false, then only false, otherwise true. I did not get anywhere. I did not get this anywhere. Nowhere I am getting true implies false. So all are true. And this completes the truth table for the given statement pattern. I hope you all have followed. You can watch this once again. Let's study now few special types of statement patterns. So in special type of statement patterns, the first one we have is tautology. So what is definition of a tautology? When the truth value of a statement pattern, is always true, it is always true, irrespective of the truth values of its component statements. Whatever be the truth values of component statements, irrespective of that, the truth value of the given statement pattern will always be true. In such cases, then such a statement pattern is known as a tautology. And as you saw here, students, in this example, we noticed that the given statement pattern here, it has truth value always true. You can check the truth value in all different possible combinations. It is always true, irrespective of the truth values of P, Q, and R. Whatever be the truth value of P, Q, R under different possible combinations, here this is always true. So what we say? We say that such statement pattern, this is a tautology. This is a tautology. This is the definition. So when the truth value of a statement pattern is always true, irrespective of the truth values of its component statements, then such a statement pattern is known as a tautology. Then we have next one as the next special type of statement pattern is contradiction. The first one was tautology. Now see, what is definition of a contradiction? When do we say a statement pattern is a contradiction? Okay, it's going to be very simple after having understood what is a tautology. See here, when the truth values of a statement pattern is always false, it is always false. In tautology, what it was always true. Here, contradiction, when the truth values of a statement pattern is always false, irrespective of the truth values of its component statement, irrespective of the truth value of its component statements, then such statement pattern is known as a contradiction. It is known as a contradiction. What does it mean, students? Think if I had obtained, if I had got all F here. It is not F here, right now it is T, but I'm just asking you to assume that suppose you had a statement pattern here, suppose you had a statement pattern here for which we had obtained all under its column, if all were F, then what we would have said? We would have said that this statement pattern is a contradiction. Then this statement pattern would have been a contradiction. Then after contradiction, we have the next as contingency. Now let's define what is a contingency kind of a statement pattern. We have done tautology, we have done contradiction. The next one is contingency. So definition of contingency statement pattern is when a statement pattern is neither a tautology when a statement pattern is neither a tautology nor a contradiction, then such a statement pattern is known as a contingency. It is known as a contingency. Okay, the definition is very simple here. When I see a statement pattern is not tautology, it is not tautology, and it is also not contradiction. It is none of the two. That is, I find in the truth table that I am not getting all T, neither I am getting all T, nor I am getting all F. So what I am getting? I am getting the mix of two. Suppose you have a statement pattern here for which when you prepare the truth table, okay, I'm just making you assume that suppose you construct or prepare a truth table, and in this truth table you notice for a statement pattern, suppose here is a statement pattern, and for this you found T, T, F, T, F, T, T, F. Now, do we have all T? No, it is not a tautology. Do we have all F? No, so it is not a contradiction. So what kind of statement pattern is this? It is not a tautology, it is not a contradiction, it is a contingency. It is a contingency. I hope you must have followed this. So we defined a contingency. See, when a statement pattern is neither a tautology nor a contradiction, then such a statement pattern is known as a contingency. Let's solve one more problem here. Question number 3. Prove that the following statement pattern is a tautology. So what is the given statement pattern here? It is negation P or negation Q in a bracket, double implication, negation P and Q. Okay, so let's make the truth table. Students, you know, since we have to get whether we have to prove that this statement pattern is a tautology. This statement pattern is a tautology. We have to prove. What we will have to do first, we'll have to prepare the truth table. So the answer will begin here. How many statement patterns do I have? I have two statement. How many? I'm sorry. How many component statements I have? Component statements. So the answer is 2. One is P, the other is Q. I have two component statements. So how many rows I will get? I will get 2 raised to 2, that is 4 rows I will have to prepare for the truth table. Okay, and one header I will have. So here I go for the header. So I have header. I have a header here. Then as you know, students, since I have two component statements, so the first two will be P and Q only. So here I have P, the other is Q. Then under this P and Q, I will go for 4 rows. So 1, 2, 3, and 4. 4 rows I have got. Okay. And what will be the entry under these? It will be true, true, TTFF, TF, TF, TTFF, TF, TF. Okay, this is header. Then as I told you, what I will do, I will go for the negations. So here, see, P and Q are done. Now I go for negation P. This is one column. I go for negation P, one column. Then I will also go for negation Q, another column. See, I'm moving from left to right. So negation P, negation Q, I will go for. Then I will go for this bracket. What is this bracket? It is negation P or negation Q. I will go for this bracket. Okay. So I go for this column. Then I will go for P and Q. See, I will go for this bracket. P and Q. I will go for P and Q. P and Q. After P and Q, I shall go for negation of P and Q. Negation of P and Q. Okay. Finally, we shall go for negation P or negation Q, double implication, negation of P and Q. That is this column and this column. We have the double implication of these two. So I have here negation of P or negation of Q, double implication, negation of P and Q. Okay. So see, students, there is something very important that I'm going to tell you now. You know, I did follow the formula 2 raised to n, that is 2 raised to 2 equals to 4 for rows. For the number of rows, I did follow the formula, but if you check, I did not follow the formula for the number of columns. Okay, I did not follow it. What I mean, I have two component statements, and how many connectives I have? See, I have how many connectives? 1, 2, 3, 4, 5, and 6. I have 6 connectives. So M equals to 6. So M plus N is equal to 6 plus 2, that is equal to 8 columns. 8 columns. But did I follow this formula? No, I did not follow the formula. I tell you, I did this deliberately because I wanted to tell you that if you do not follow the formula for columns, still you can go ahead. Still you can go ahead. You just have to follow that you take the negations first. See, if it is P and Q, the two columns are always fixed. Then you will check the negation of the component statements. I had negation of P, negation of Q, so I went for that. Then I saw that these two are in brackets, so I went for that. Then I saw there is one more bracket, P and Q, I went for that. Then I saw that I have negation of this, I went for it. And then finally, having got this and this, I went for the complete statement pattern. And if you check how many columns I have, how many columns, I did not know in the beginning that I have to go for 8 columns. I did not know it. But since I followed the correct method of doing it, I have got required number of columns. So let's check how many columns we have here. Let's check how many columns we have here. See, 1, 2, 3, 4, 5, 6, 7, 8. Bingo. Yes, we got 8 columns. We got 8 columns. Okay. So let's now fill this up. We are going to make the entries here. So see here, P. P, what you have, P, T, F, F. So negation P, what you will have, you will have F, F, T, T. It is negation of what you have under column P. Then negation of Q. Q is T, F, T, F. So here you will have F, T, F, T, F, T, F, T. Then here you have negation of P or negation of Q. So remember, students, what it is. It is negation of P, or you have disjunction of these two. Okay, that is column 3 and column 4. You have disjunction of these two. You know the law of disjunction. The law of disjunction says when both are false, then false, otherwise true. So see, both are false, false. Both are false, no, true. Both are false, no, true. Both are false, no, so true. Both are false, no, so true. Next, P and Q. I go for next column, P and Q. That is this column and this column. Okay. Now what does it say? The law of conjunction says when both are true, then true. Otherwise false. So true and true, true. Okay. Are both true? No. False, false, and false. Then the next column is 7. It is negation of P and Q. That is negation of this column. So here, see, true, false. So this becomes, if it is false, then true, true, and true. Then students, see here, what is next? The next one says that we have the double implication. We have biconditional of column 5 with column 7, column 5 with column 7, this and this. Okay, let's begin, students. Let's begin. What is the law for biconditional? The law for biconditional is when the component statements have same truth value, then the biconditional statement will be true, otherwise false. So see here, are they same? We will have to check. So see here, F, same, so true, 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 TT, same, so true, 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 same, so true. Great. And see, students, what you got? You got all true. You got all true. So since you got all true, what you will say? You will say that this statement pattern, remember students, you will say that this statement pattern here is a tautology, and hence proved. Okay, so its answer, how do we write the answer? I shall tell you how to write the answer here. Okay, let me write the answer for you all. The answer will be I write all the entries in column number 8 are true. All the entries in column number 8 are true. Therefore, the given statement pattern is a tautology. I hope you all followed this. Okay, let's solve a problem where we have to prove that the following statement pattern is a contradiction. So we just solved a problem where we proved that the given statement pattern was a tautology. And students, what we noticed that the column in which the truth table column where we had the statement pattern, all the entries were true. And since all the entries were true there, we said that the given statement pattern is a tautology. In this question, we have to prove that the given statement pattern is a contradiction. So what will happen, as we have already learned the definition of contradiction, this statement pattern will be a contradiction when the truth value of this statement pattern will always be false. It will always be false irrespective of the truth values of its component statements. That is, irrespective of what P and Q are, whether P is true, Q is false, P is false, Q is true, irrespective of that, the statement pattern, given statement pattern, will always have the truth value false. In that case, we will say it is a contradiction. So let's make the truth table for this. So our answer will begin from here. So how many component statements we have? We have 2 component statements. Those are P and Q. So total 4 columns we will have here. Okay, so I'm sorry, 4 rows we will have here. And in these 4 rows, above these 4 rows, we will have the header. Okay, so the first thing I do is I make the header. Header is P and Q. So P and Q, and after that I have to make 4 rows. So I have here first row as this, then second row, I have to make 4 rows, third row, and the fourth row. I have got 4 rows here. I've got 4 rows. Fine. Then I have to go for the column. Okay, let's make the entries under these P and Q. You all know what the entries will be. It will be TTFF, TTFF, TF, TF, TTFF, second column TF, TF. Now we go for the number of columns. See, there are 2 ways I can go for the number of columns. In beginning only I can know how many columns I'm going to have. So n is 2 because the number of component statements are 2, and the connectives, check how many connectives we have. So 1, 2, 3, 4, and 5. So m is 5. So total m plus n, we are going to have 7 columns. Okay, so let's go for the 7 columns here. And for writing the columns, I have already told you we will first go for the negations. And then we will also take care of the parenthesis. At the same time, we will move from extreme left to right. Okay, so P and Q are done. Do I have negation P and negation Q? Yes. So I will write here negation of P in one column, This is negation of P I have. Negation of P I'll have in one column. Then I shall have negation of Q in one column. Okay. Then I will follow this bracket, which is P or Q. I will have P or Q here, P or Q in one column. Then I will have the next bracket. Next bracket is negation P or negation Q. I will have negation P or negation Q. Then having done this all, now I shall write the complete statement pattern. In the final column, I will have the complete statement pattern. Which is P or Q and negation of P and negation of Q. This is the final column. We are now going to make the entries in these columns here, but before that, let me number the columns. So here I have 1, 2, column number 3, column number 4, 5, 6, and 7. So let's go for the entries in negation P. You know the law of negation. If P is true, negation P is false. So here false, this is false, true, and true. You can check. P is false, so true, false, true. Negation P. Now Q, negation Q. Q is true, so negation Q is false. Here true, this is false, and this is true. Okay. Then P or Q. You know the law for P or Q. When P, Q both are false, then false, otherwise true. P or Q. So here, this is true. This is true because both are not false. This is also true. Here both are false, so false. Then we have the conjunction of, we have the disjunction. We have the disjunction of negation P and negation Q. That is column number. Which column number? Column number 3 and column number 4. We have the conjunction, I beg your pardon once again, we have the disjunction of these two, negation P and negation Q. Got it? So disjunction, you know the law. When both are false, then false, otherwise true. When both are false, then false, otherwise true. So see, false, 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 true, 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 and true, and true. Then seventh column. Now I have to make the entry for the conjunction of what I have in column number 5 and column number 6. I have to make the I think somewhere I have committed a mistake. Let me check, students. P or Q, this is oh, here I made a mistake. So let me first correct this. Okay, it is not disjunction. It is actually a conjunction here. See, you can check, it's a conjunction here. So this is conjunction, and because of that, these all entries will change. These all entries will change here. All the entries here will change. I'm sorry. So what will be the entry, students? We have the conjunction of negation P with negation Q. Okay. So yeah. So it is column number 3, column number 4. I have conjunction. You know the law of conjunction. When both are true, then it is true. Otherwise, false. So we have here both false. It is false. This is also false. This is false. And here both are true. So it is true. Okay. Now we have the conjunction of what we have in column number 5 and column number 6. We have conjunction of these two, right? Okay, so you know the law of conjunction. We have conjunction of these two. You know the law of conjunction. When both are true, then true. Otherwise, false. So you can check false, 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 false. So what you notice? You notice in the column number 7, that is for the truth value of the given statement pattern, you can notice that we have all the entries false. We have all the entries here false. Okay, so we notice that irrespective of the truth value of P and Q, this statement pattern is always false. You can check, always false. So this statement pattern is a contradiction. So here we write the final answer. I will write the final answer as all the entries in column number 7 are false. Therefore the given statement pattern is a contradiction. It is a contradiction, hence proved. I hope you followed. You can watch this once again. So the way we proved for a statement pattern to be a tautology, and here we proved that a statement pattern is a tautology, and here we proved that a statement pattern is a contradiction. We can also, for a given statement pattern, we can prove that the given statement pattern is a contingency. In case of contingency, what you will see is the last column where you will have the truth value of the statement pattern, you will neither have all true nor you will have all false. You will not have all T, you will not have all F. So what you will have is, it will be the mix of T and F. If you have mix of T and F, then you will call it as a contingency. You can solve number of problems based on this. So today's lecture was quite informative. You can watch this video again and again and understand this. Thank you. Whichever textbook or the reference book you are referring to, in that textbook you will find number of problems. Whichever board you are from, you will find number of problems of such type. So you can practice all those problems and you can get the ideas about it. So I would suggest you that you follow the questions from your own board, whichever board you are following or whatever textbook you are following, because the ideas and the laws will always remain the